Okay, question 30. The function f of x equals this is graphed in the plane above. If k is a constant such that the equation f of x equals k has three real solutions, okay, which of the following could be the value of k? So f of x equals k is like y equals k. So let's like y equals, for example, 3 would look like that, right? And we want three solutions, so we want it to cross 3 times. So it looks like something like this would do the trick. So it would cross 1, 2, 3 times. So if we add a -3 height, which answer choice D has, then that would be the ticket. Okay, y equals -3. Okay, so we're into the grid ends. A partially filled pool contains 600 gallons of water. A hose is turned on and water flows into the pool at a rate of 8 gallons per minute. How many gallons of water will be in the pool after 70 minutes? Okay, so you have 8 gallons per minute times 70 minutes. Okay, we're multiplying them together so that the minutes will cancel out. 8 times 7 is 56, so that's 560 gallons that are added to the pool. But there's already 600 gallons in the pool, so that's a total of 1,160 gallons. The normal systolic blood pressure for an adult male X years old can be modeled by this equation. According to the model, for every increase of 1 year in age, by how many millimeters of mercury will the blood pressure increase? So they're talking about the slope, okay? So for every 1 year increase in X, what would happen to Y, okay? So if we were to write this 2 out for each one separately, we'd get X over 2 plus 220 over 2. We could do that because it's a common denominator. So then this reduces to 110, and this is like a 1/2 out in front of your X. So that is our slope M, okay? So that means that a change in Y of 1 would respond to a change in X of 2, or you could think of it as a change in Y of a 1/2 would respond to a change in X of 1. So our answer is just 1/2. The pes, a Roman measure of length, is approximately equal to 11.5 inches. So 1 pes is 11.65 inches. It is also equivalent to 16 Roman units called digits. So it's also to 16 digits. Based on these relationships, 75 digits is equivalent to how many feet? Equals how many feet? Okay. We also know that 12 inches equals 1 foot. All right, so we have the problem laid out here. So we have to convert digits into feet. So let's see how to get there. Starting with 75 digits, we'd like to get out of digits. So we have to use something that involves digits. For example, we can use this. So we know that 16 digits corresponds with 11.65 inches. Okay? The digits would cancel, leaving us in inches. But we want to go further than that. We want to get out of inches. So we put inches on the bottom and we can put feet here. 12 inches is 1 foot. So we would get the inches to cancel out. So if we do the math correctly, we should now be in feet, and therefore once we get the right unit, we should certainly have the right answer. So let's check the numbers. So here we have, let's see, 75 times 11.65 times 1. So I'll just do the whole numerator first. And then we got to divide by 16, and we also have to divide by 12. Divide by 12. Notice how I do those separately, otherwise you might get a wrong answer. So yeah, we end up with 4.55 feet. Okay. Yeah, 4.55. In a study of bat migration habits, 240 male bats and 160 female bats have been tagged. If 100 more female bats are tagged, how many more male bats must be tagged so that 3/5 of the total number are male? Okay. So right now we have 240 male, okay, and we have 160 female. All right. Then we add 100 female. So now we have 260 female. So right now our number of male bats is 240. Our number of female bats is 260. So our total is 240 plus 260, right? Which is, let's see, 500. So this is our total. So here's the trick for this question. We have to let X represent the number of male bats that we're going to add. Number of male bats added. Then, so we would add them to our numerator, because our numerator is the number of male bats total. Right now we have 240, and we're adding X. But we also have to add X to our denominator, which is currently 500, but when we add, let's say, 10 more male bats, it's going to be 510, right? And then after having added that, we set it equal to 3/5, right? So then we just have to solve this for X. So we have to cross multiply, remembering that these binomials have parentheses around them. So we get 5 times the quantity 240 plus X equals 3 times the quantity 500 plus X. Okay? We distribute the 5. So that gives us, let's see, just use our calculator, why not? 5 times 240, and that's 1200. So 1200, and don't forget to distribute also to the other piece. That's going to equal 3 times 500, which is 1500, plus, and don't forget to distribute that, 3x. Then we deal with the x's first, so we subtract 3x, gives us 2x. We subtract then the 1200, and that gives us 300. We divide by 2 both sides, and that gives us x equals 150. So 150 more male bats, and we'd have our 3/5 ratio. All right, Q equals 1/2 NV squared. The dynamic pressure Q generated by a fluid with velocity V can be found using the formula above, where N is the constant density of the fluid. An aeronautical engineer uses the formula to find the pressure of a fluid with velocity V in the same fluid measured with velocity 1.5 V. What is the ratio of the dynamic pressure of the faster to the slower? Okay. So what we want to do is we want to apply a stress to this system. We want to change V into 1.5 V and then measure the response on Q. We want to know what happens to Q when we do that. Okay, so what we do is we plug in 1.5 V into the formula. So we have Q, we have Q equals, right, 1/2 times NV squared. But now, instead of V, we're plugging in 1.5 V. So we have 1.5 V squared, again, with the 1/2 and the N. So this is going to be our new Q. So when we do that, notice we have to square both pieces. So what we end up with is 1/2 N, and then 1.5 squared is 2.25. And then, of course, V squared. So if we just rearrange this a little bit, we have 1/2 N times V squared times 2.25. So this is the original, and what happens is it gets multiplied by this number 2.25. That's going to be our answer. Because if we take the new amount, which is this, we divide it by the original, notice that all this would cancel out. In the figure above, the circle of center O and has radius 10. So we can label these as 10. The length arc AB is between 5 and 6. What is one possible integer value of x? We don't know what this value is, but it's between 5 and 6. So we can write that like this. Okay, so one way to do this is to use arc length formula, right? We can also use an idea of circumference. I like the idea of circumference here. So circumference is 2 pi radius. So circumference in this case is 2 pi times 10. So the circumference would be 20 pi. And if we multiply that out, 20 times pi, that would equal 62.83. 62.83. Okay. So now, let's see. We want we want a certain fraction of that. What is one possible value? Okay. Right. All right, so here's one way we could do it. So whatever the value of BA is going to equal, we'll put that there, and then we'll put this over 62.83, and that's going to equal x over 360. Okay, so notice that I have on the bottom both totals, both for the degrees in a circle and also the total circumference, and then BA is a part of that circumference, and x would go basically right here. Okay, x, of course, being the degree measure of this interior angle out of a total of 360. Okay, and we know, yeah, that this is between 5 and 6, so we could try 5, we could try 6, and see what happens. Okay, so let's start with trying 6. So we just have to multiply by 360 to solve for x. So grab the calculator, we do 6 divided by answer, and then times that by 360. We get 34, so x equals 34 point something, 0.37. And then if we, so this is at 6, and then if we try it at 5, right, try at 5 with this number, then we'll do 5 divided by 62.83, and we multiply that by 360, and we get 28.64. 28.64. So some number in between of there. So let's just use 29. Okay, we could also use 30 all the way up through 34.